Hello everyone. My mini project topic is automated electronic toll collection system using RFID. So let me first tell you the main objective of my project and then elaborate what project is actually about. So let me come again. My project name is automated electronic toll collection system using RFID. Now the main objective of this project is to save fuel. So before discussing about the objective of the project, let me tell you briefly what project is about actually. So basically, you must have had this experience on toll plaza or toll gate when vehicles cross on the national highways from one place to other place or from one state to other state. Whenever they cross the national highways, they have to go through something called as toll gates or toll plaza. So there, the vehicles have to pay taxes. So this tax is collected by the central government. Actually, this is called as transport tax. So vehicles have to pay tax manually while crossing on the national highways. Now the problems we face in India are the system is not efficient. I mean, this tax is collected manually by a person on the toll gate or toll plaza. So due to this, what happens is lot of vehicles have to stand in a queue in order to pay the tax because there is no direct system to collect the tax. There is no electronic system to collect the tax. So therefore, what happens is a person manually has to collect the taxes, right? Now, for example, now when a person is manually collecting the taxes, the vehicle has to stay there at least for a few seconds. Now, let's say the vehicle has to wait for 1 minute in order to pay the tax. Let's say 60 seconds. Now, if a vehicle takes 60 seconds in a day to wait there to pay the taxes, that too in the engine start mode. That means the fuel is consuming while he's paying the taxes. Now, in one day, it is using 60 seconds. Now, in 30 days, 30 into 60, that's somewhere around 1800 seconds. So, the vehicle is in engine start mode for about 1800 seconds in 1 month. Now, in yearly, 1800 into 12, that would be somewhere around 6 hours. That means one vehicle is in engine start mode for 6 hours at the toll plaza gate to pay the taxes. Now, imagine how many vehicles are passing through those toll plaza. Imagine 100 vehicles are passing through the toll plaza. So yearly 100 into 6, that is 600 hours. 600 hours. I mean, all vehicles, these 100 vehicles have to wait there for 600 hours, that in engine start mode at toll plaza. Now imagine how much fuel is been consumed and how much pollution that is been causing, right? A lot of pollution, right? But to overcome this, we have come with there is a project. I have come up with a project called as automated electronic toll collection system using RFID. RF stands for radio frequency ID. Now, the main objective of this project is, as I said, the main objective of this project is to save fuel. Because since I have given one example that the 600 hours waiting in the engine start mode, so obviously this fuel will be saved, and then the time would be reduced, right? And then the time would be reduced with this project, with this automated toll collection system, and then the reduces the illegal toll entries, and then safe and fast payment methods. These last two things, I'll explain to you like how we do that. I mean, how these last two objectives are met. As soon as we proceed into the project, we'll be able to get to know all these things. Okay. So the main abstract of this toll collection system is basically what happens is at the toll plazas or toll gates, a person manually collects the tax from the vehicle. A vehicle has to stop there. So what we have come up with the project is in this project, according to the project, each vehicle will be having a RFID. So this RFID would be assigned by the RTO or the transport system that is been operated in different states. So basically that is RTO that has been operated in our country, Road Transport Office. So this RTO system, this RTO assigns each vehicle a RFID. So this ID will be having a unique bar, or you can call it unique number or unique bar. Okay, the white and black strips bar. Now this unique number will be consisting of all the basic details of that vehicle, like what is the number, all the basic things that a vehicle consists of. And along with that, it will have a separate column called as this tax paying toll column. So this toll column, what it does is it keeps track of how much money has been paid in the form of taxes while crossing at the toll plazas, and how much time has been saved, and all these things. Okay. Now, as it goes, automated electronic toll collection system is used to collect the toll taxes of the vehicles using the radio frequencies. I'll tell you how these radio frequencies are being used while we discuss the project. Now, every vehicle which crosses the toll needs to have RFID tags, as I said, which are used for unique identification. Now, these RFID tags are assigned at the respective RTOs where the vehicle registration takes place. And then, so the process takes the less time to pay toll taxes using this RFID technology, and fuel is also saved. Now the introduction. So let me move on to the introduction of this project. As I said, each and every vehicle will be having a RFID tag. So RFID tag will be keeping track of all these things. So here what we do is we'll assign a wallet to the each and every vehicle using this RFID, so that each wallet will be having a balance. I mean, prepaid by prepaid, the vehicle owner should top up the wallet with the prepaid balance. Now, whenever vehicle crosses to the toll plaza, RFID reader, a system will read that RFID tag, and the amount will be deducted automatically, and then the permission will be given for the vehicle to move on. Okay, this is how the process takes place. So the project majorly focuses on an electronic toll collection system using radio frequency identification technology. Okay, so the RFID system uses tags through which information embedded on the tags are read by RFID readers. The proposed system eliminates the need for motorists and toll authorities to manually perform ticket payments and toll fee collections, respectively. So the main objective of this e-toll project is to collect funds to finance the construction and maintenance of the road network. In addition, e-toll facilitates the delivery of sophisticated services based on information that the system is able to collect. The second benefit is that let's say the driver doesn't have to carry the money each time. As I said, there will be a wallet containing the wallet. The vehicle owner has to top up the balance in the wallet, balance the wallet. So that's how automatic collection will happen. So the driver no need to have to carry the money always in order to pay the taxes. He will just recharge the RFID card by certain amount, and then will use this card each time he travels. That's it. A very simple. So this is the main idea of this project. Okay, nothing but in simple words, automatic tax collection at toll plaza or toll gates. Now let's see how to build this. What are the major components that are present in this project, and what do we have to build it, and what I have built in this project. Okay, this is the outline. So first we'll be discussing the components required, and then we'll be discussing the circuit diagram, and then the working process, and then the advantages, disadvantages, and then finally the conclusion of the project. Okay. Now these are the components required. So the components required are, one is the Atmega 32 microcontroller, because since we are dealing, so a microcontroller is very important because this controls the each other components. So here in our project, we'll be using a Arduino Uno as a microcontroller. And then obviously we'll be having a power supply DC motor, 5 volts each, and then an LCD module. I'll tell you where LCD module is used. Soon as we get into the more details, we'll get to know why LCD module is used. And then few capacitors and resistors in order to maintain the frequencies. And then a motor driver, and then the reader module. Okay. Now this is a block diagram. You can see the microcontroller over here. This microcontroller is nothing but the Arduino Uno. And these are the different components that I have told you right now. These components will be connected to this microcontroller. Okay, this is how the components will be connected to it. The keypad, the buzzer, the LCD, all these things. Why do we use it? We'll get a complete clarity as we move forward into the project. This is a circuit diagram, a complex circuit diagram, I would say. So this is a very complex circuit diagram. You can see this is the microcontroller, and to the microcontroller, all other components have been placed. Have been connected. And then what are the uses of these different components? I'll explain you in the project. Okay. Now this is the Arduino Uno Atmega 328P microcontroller, which is used as a microcontroller, and then the LCD screen, and then the this is a pin diagram of this LCD screen. Okay. Now, before moving on to this IR transmit diagram, IR receiver diagram, because you should know why this transmitter circuit diagram, receiver circuit diagram is used. So for that, first we'll discuss about the pictorial representation. Why do we need that components? Okay. So in order to know why do we need that components, first we should know what are all the components that are being used in this project. Now, if you see here, this is the toll plaza. right? So if you can watch my mouse here, this is a toll plaza, or you can call it toll gate. This is a vehicle. Okay. So previously, manually, what happens is in India currently, when the vehicle passes, vehicle has to wait here for a few minutes, so that the person who is present at the toll plaza will verify the details of the car or the vehicle, and then he'll manually takes the tax and then allow the vehicle to move on. But now what happens is in our project, this vehicle will be having a RFID tag. So the tag will be containing a unique identification number through which we'll be knowing all the details, and then we'll also be knowing the wallet, RFID wallet, and then here we'll be having a antenna. So this is called as RFID reader. Now this RFID reader, what it does is it reads this information. It reads the tag, and then the amount will be detected automatically. Okay, based on the RFID readings. Okay, the antenna is based on this antenna. So whenever the antenna reads the information, then the system gets the information at the transmitter side. And the transmitter transmits the information, and at the RTO office there will be a receiver. The receiver receives the information. That information is then again matched with the database that we have or that we maintain at the RTO office. Now, the data that has been collected by the antenna and then processed by the transmitter and the receiver will be matched with the database we have, and then the processing happens, like the tax payment, the automated deduction of the tax amount. Okay, this is how it takes place. So you can see it's a pictorial diagram, right? Now, what are the major components involved in it? One is RFID tag. As you see here, the RFID tag is very important, that is placed on the vehicle. And then the RFID reader, the antenna which actually reads. And then we need a transmitter, we need a receiver, and then a database. So I'll not include database in this project because database is something which belongs to different domain. We will not build this. We'll only be building antenna, transmitter, and the receiver. Okay, RFID reader, transmitter, and receiver. Now let's go back to the component. This is a whole circuit diagram. This is a micro. This we have already discussed. Now this is why we need a transmitter circuit diagram. So you can see here, this is a transmitter. So this circuit entirely acts as the transmitter. Okay, I mean transmitting information from the antenna. And then this is the receiver circuit diagram. The transmitter which got the information that will transmit to the receiver, and the receiver at the end, I mean at the office, will be collecting this data and then processing through the database. So this is how, this is a RFID module. Okay. This is the RFID module which we use to read the information that is present on the RFID tag. This is how the connections takes place. Now, why do we need the LCD display? We need LCD display in order to display how much amount has been detected and what are the basic details of the vehicle. I mean, whenever the antenna or the RFID reader reads the information that is present on the RFID tag, then we have to display it. So using this LCD display. So we have already discussed the pictorial representation, right? Now let's move on to the working procedure. As I said, there will be three things that will majorly be taking place in this project. One is detection of the vehicle. When the antenna reads, the vehicle will be detected, and then the information will be displayed on the LCD, and then the payment through the RFID tag. So before this payment, there will be different receiving and transmitting of the data, and then manually cross-checking it with the database, and then the deduction of the amount automatically. Okay. So the above mentioned three parts are the working procedure of this project. So whenever a person buys a vehicle, he or she registers the vehicle at the RTO office. You know this. So in the same process, the vehicle will be assigned with the RFID tag, which will consist of a unique identification number. So whenever the vehicle passes the toll station, the receiver at the toll point receives the amount from the smart card provided to the owner. As I said, RFID wallet. Okay. Now, if the transaction is been declined, as I said, there will be a smart wallet already present. The vehicle owner has to top up, recharge it prepaidly, right? Before he has to recharge. Now, let's say the amount is there is no insufficient balance. The vehicle owner has forgot to recharge the card. Okay, now there will not be insufficient balance. So there will not be any deduction of the amount. That time, what happens is if the transaction is been declined due to insufficient balance or by any other issue, the vehicle need to pass through other lane, a separate lane, where the payment can be paid manually, or any queries or any issues, inefficient issues can be reported to the RTO website using the smart card ID provided. Okay, so this is how everything takes place. Now let's talk about the advantages of this project. Now it takes matter of seconds to complete the entire process, and there will be safe transactions. It increases the revenue or the curbing leakages and ensuring smooth travel across the country. There will not be any traffic jam at the toll plaza gates, and illegal vehicles can be easily detected using this project as well. It is capable of eliminating congestion in the toll plaza, especially during those seasons when traffic seems to be higher than normal. You can also reduce the air pollution that is been caused. The electronic system records transaction including time, date, plaza, and toll charge of each vehicle. And then we'll be having better control over the transport system as well. The scope of this project, whenever the matter of integration of systems comes into mind, we think of a system having the following important features like accuracy, efficiency, and cost effectiveness. And the project has these three things. There is accuracy, all the functionality, bonded logical dependencies must be integrated. And then the efficiency, the whole system should work under all circumstances. And on a long run, it should work efficiently, irrespective of their proprietary format, and the cost effectiveness. As our software do not require any special software for implementation, hence it is less costly as compared to the other existing system. Now coming to the disadvantages. Well, uh, as I said, the project we have designed that will not be working for the big system, right? But the toll plaza that is present here. In order to make it work, we need more efficient components for which it costs high. And if RFID fails, the whole system fails, right? If the antenna, if the RFID reader that is been reading the RFID tag, if it fails, let's say if it fails, there will be a lot of traffic jam. Then, in order to repair it, someone should come and then repair it. It takes time, and then there'll be the whole system fails. Actually, there will be a lot of traffic jam, and that will lead to some incongestion actually. If the amount is not sufficient to pay toll, then the user must have to pay the toll manually. If the user has to pay the toll manually, then the same thing happens. The whole system comes into effect. And then overhead reading. What happens if failed read? The fourth point actually comes into the second point actually. Now coming to the conclusion. So by following this technology, we can reduce the money loss at toll gates with reducing the manpower, traffic, and time taken as well. Here we are using RFID tags, radio frequency integration tags. So and tag readers to sustain the manpower, and the whole process leads to safest and fastest payments across the country. That's all. Thank you. I mean, before ending the project, I'll just like to show you the demo of the project, how it works and all.